Okay, so we're gonna go ahead and get started. I'm gonna mute a few people because I can hear some stuff going on in the background. Okay, let's see. Did I mute everybody? Okay, so we're gonna go ahead and get started now. Okay, then we're gonna let's see. So we're at the play. Here we go. Okay, so today we're gonna be talking about pretty much whole numbers and decimals. Uh, this presentation should take about 45 minutes to an hour. Then after the presentation, we'll field questions about Alex, about the FSO platform, and about the up and coming project. Okay, once we're finished with the lecture, if you don't have any questions, um, you're free to go. If you got questions, if you want to hear other people's questions, you're free to stick around and listen to those questions as well. Okay, so math is the study of patterns. Okay, there's only really two things we do in math. We count forward and we count backwards. Again, everything else is just a sequence or a derivative of that counting forward and counting backwards. We believe that math is a universal language. It's actually the language of the entire universe. Okay, so math is a language. Understanding the language means that we have to understand some basic math concepts or definitions. Our number system as we relate to it is a Dewey Decimal number system. It's based upon 10 digits. Okay, we in algebra we talk a lot about real numbers. Okay, real numbers are any numbers that you can place on a number line. Okay, with real numbers they're broken down into two sets of numbers: rational numbers and irrational numbers. Okay, the simplest sort of the most basic real number we come across are counting and natural numbers. Okay, and counting and natural numbers, of course, are rational numbers. Rational numbers terminate or repeat. Uh, the next most basic or simple number that we'll come across are whole numbers. Whole numbers are also rational numbers as well. Whole numbers are different from natural or counting numbers in the sense that there's one additional number, which is zero. And then we have our integers. Our integers include the negatives. And of course, rational numbers are your whole numbers, your counting numbers, your integers, and any number that can be expressed as a fraction as well. Okay. Or decimals that repeat. And then we have our irrational numbers. Okay, irrational numbers are non-terminating, non-repeating decimals. The most famous irrational number is pi. Okay, and here's a breakdown of our real number system. Right here we can see that we're basically talking about rational numbers and irrational numbers. All of these other numbers that we just talked about, integers, whole numbers, and natural numbers or counting numbers are all part of our rational numbers set. Okay, someone said they're not receiving any audio. Um, okay. Let me see. We have that problem often. Let's see. Try turning up your volume. Try turning up your volume. Okay. Okay, so that's our real number system. Okay, and digits, we have 10 of them in our decimal number system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Digits make up numbers. Digits are basically symbols. They don't have any value to them. Like a zip code is comprised of digits. It's not a quantity or a specific amount. Okay, numbers have quantitative value to them. Okay, we can compare them and we say that they have an absolute value. We can compare them and one will be larger than the other one. They have meaning. Let's go back to variables. A variable is something that we're going to see a lot in algebra. A variable represents an unknown number. Okay, so when we don't know what the number is, we put a variable in there. Case in point, let's say if we had something like 3, we'll put a center dot here, times some unknown number plus 5. Okay, that could also be expressed as 3y, and it can be x as well. I just want to use something different than x this time. 3y plus 5. And so that y is some unknown number, and what we're saying is 3 times some unknown number plus 5. As we move forward, we'll start to look at the relationship between multiplication and addition, and then the relationship between addition and subtraction, and then the relationship between subtraction and division. And so we'll see that patterns will start to evolve as we examine those relationships. And that's really what math is all about, the study of patterns. Okay, here's our 4 basic operations: addition, subtraction, multiplication, division. Okay, those are operations. And then we have our comparison symbols. Okay, so these 4 right here are operations. And these 3 right here are equality or comparison symbols. We have equality symbol, which is the equal sign, and then we have the inequalities, which is less than or greater than. We have other inequalities. We have other equality symbols as well. We got the equal sign, but we also got the approximate to sign. Well, we do that right there, the wave symbol. So that's an equality symbol as well. Okay, and the less than and greater than are not the only inequality symbols. We have less than, equal to. We have greater than, equal to. And then this is one that a lot of people forget about, the not equal to. Okay, that's also an inequality symbol. Okay, so we have multiple comparison symbols. We have the equal, the approximate symbol, approximate in the sense of estimating. We have the inequalities, which are the less than, greater than, less than, equal to, greater than, equal to, and then not equal to. Underneath, a little additional exploration of our basic operations. Okay, those basic operations you should get real familiar with. You're going to see them a lot in math. I mean, you're going to see them a whole lot. Understanding each one of those basic operations is tantamount to understanding math. You can write an entire book on addition. Just that one operation, you can write a book on it. Okay, we need to know how that operation works. We need to know the inverse of the operation. We need to know the definition for the operation. What happens with that operation with, numbers versus variables versus terms versus radicals. Okay, so, and then we also need to know how to identify that operation in a word problem. Okay, we got some key concepts to let us know when we're supposed to be adding, like the word add, sum, and, increase by. Okay, those are all key concepts that let us know when we're reading a word problem that we're supposed to add. The addition operation only has one symbol. Okay, and so we can see it there. Subtraction only has one symbol as well. We have a few key concepts when we're working with subtraction. Less than, decrease by, difference, and change. To subtract. Subtraction is the inverse of addition. Okay, so if we want to undo addition, we can undo it by simply subtracting whatever's being added. Multiplication and division are a little bit unique in the sense that they have multiple symbols to express those operations. We have the multiplication symbol. Typically, we don't use that multiplication symbol in algebra because it can be confused with an X. Anytime you see two letters next to each other, like A and B right next to each other, that's going to be multiplication. The parenthesis is also a multiplication symbol. Now, with that parenthesis, it can also be considered a grouping symbol too. Like, let's say if we've got this right here, I'm gonna put that a B next to it like that. Okay, in this case, that's a multiplication symbol. Okay, if we have like this right here, A plus B, okay, minus C. Okay, that's not a multiplication symbol there. Okay, here, that's a grouping symbol. Now, what makes it a grouping symbol? It's a group. In order to be a group, you got to have two or more. The one above here, that's not a group. Okay, that's a multiplication symbol because you've got one individual inside the parentheses. You got to have more than one thing inside the parentheses for it to be a group. Okay, so in the order of operations, that multiplication is going to come after the exponents. In the order of operations for the second one, that's going to come first because it's parentheses, exponents, then multiplication, division, and then addition and subtraction. Okay, so that it's important for that reason. It's important for other reasons too. We just got to be able to recognize when we see these symbols, whether it means to multiply or whether it means a group. You'll know because if it's a group, it will have two or more. Okay, if it's multiplication, it'll only have one symbol inside inside the parentheses. Okay, so the parentheses, that center dot is also another way of denoting multiplication. We see that a lot in algebra. Words that mean multiply, product, times, factor, the word by, the word of, percent of. Okay, and that word, even though it says factor of, the word of literally means to multiply. Like we say 3/5 of 7, that means 3/5 times 7. Okay. Now, getting familiar with these concepts, these word concepts, are going to be very important to solving word problems. Okay, so when people are good at word problems and they like word problems, it's because they know what words tell them to multiply, divide, add, or subtract. When they hate word problems, it's because they can't recognize those words. The numbers are easy to identify because they're sprinkled all over the problem. You can say, oh, that's a number. That's easy to see. It's the words that let you know to multiply, divide, add, or subtract that are the problem when we're looking at word problems. Okay. Division has a few, the word divide, quotient, ratio, fraction. Okay, those all mean to divide. Okay, and division has four symbols here. We got the short division symbol, the long division symbol. Got the fraction bar. Yes, a fraction bar is a division symbol. Okay. And then, of course, we've got synthetic division, but that's different. That's not in here. But these are going to let us know that we're going to divide these symbols. So multiplication and division have multiple symbols. Addition and subtraction only have one. Okay, with addition, we talked about this a little early, just kind of touched on it. And we said that, that addition is the opposite of subtraction. Okay, and when we add two numbers together, we come up with a sum. Addition is commutative. That is to say that if you move the numbers around, you still come up with the same answer. Okay, and so we can see there 8, 5, and 2 were moved around in the second problem, and we still came up with 15. Now, it helps out. It makes adding faster, but in algebra, it also makes adding possible. Okay, in algebra, they're going to be things that we simply cannot add together. And so we'll need to move the terms around so that we can eventually add whatever it is we're able to add. Subtraction, of course, is the reverse of addition. The answer to a subtraction problem is called the difference. Okay, subtraction is not commutative. That means you cannot move the numbers around. If you move them around, you'll come up with a different answer. And of course, we can see the example here, 8 minus 5 and 5 minus 8 give us two different answers. So addition is commutative, subtraction is not commutative. And we have multiplication. Multiplication is a shortcut for addition. Okay, so anytime we have numbers being added together and we identify that it's the same numbers being added together, we can multiply. So 3 times 7 comes from 7 plus 7 plus 7. And that's good to understand because when we're working with exponents later on, we'll see that this understanding will benefit us and help us to gain a more insightful understanding of exponents. And here's another example. Okay, anytime we multiply a number by 0, it's going to be, the product will be 0. That'll be important when we get to factoring or solving quadratic equations by factoring. Okay, there's going to be that 0 product rule that we'll work with. Okay, and that's later on in algebra, but not right now. Multiplication, the answer to a multiplication problem is called the product. Multiplication is commutative, like addition, and it should be because multiplication is the shortcut or the short version of addition. When we're multiplying, moving numbers around doesn't affect the outcome. Reorder can help us solve problems in algebra. So 2 times 3 and 3 times 2, even though we move things around, it doesn't change the outcome. Okay, here are other ways we can express multiplication. So it's important to look at these different ways and get an understanding that these are ways that we multiply, because you will see all of these different ways in ALEKS. And because math is a language, then at some point in time, you're going to have to listen to it and read it. Okay, the numbers in multiplication are called factors. So 2 times 3 equals 6. The 2 and 3 are factors of 6. That's an important concept because those factors are going to go with us as we're working with fractions. Okay, we'll look at greatest common factors. As we're looking at quadratics, we'll talk about factoring. And as we're looking at radicals, we'll talk about perfect square factors. Okay, so we're going to see that concept factor a bit. And we got to know that that term factor comes from multiplication. That we're actually with the factoring that we're actually multiplying. Okay. Okay, when numbers cannot be factored, they're called prime numbers. Okay, in the sense that they only have one in themselves as factors. Okay, so the number 7 only has 1 and 7 as factors. And here's a list of some prime numbers. Okay, that's important. Okay, what makes it important is this right here. If you've got, let's say, 3 over 23 as a fraction, I'm going to go ahead and circle the 3 and the 23 in here. Okay, that fraction is already in its simplest form because a prime number over a prime number, they don't have any common factors. Okay, because the only factors of 3 are 1 and 3, and the only factors of 23 is 1 and 23. So that you can't simplify any further. Even if you had, say, 23 over 100. Okay. Now, when one of the numbers is a prime number and the other one's a composite number, it gets a little dicey. Okay. This one is in simplest form as long as the prime number doesn't go into the composite. So since 23 is not a factor of 100, this fraction is in simplest form. Okay. So that's the most important thing about prime numbers and composites. Okay, they're going to help us when we're simplifying. Okay, so when we're working with fractions. Okay, another thing we'll see is like if you're working with, so if you got this right here, 2/3 plus 1 over 13. In order to work these two fractions out, you can multiply the top and bottom here by 13, which is the denominator of 1 over 13, like that. And you can multiply this one by 3. So you can multiply the two denominators together to come up with the least common denominator. Okay, for this one. Okay, and that only works if both numbers are prime. Or like with the 23 over 100, if one's a prime number and the other one's a composite, and then the prime number, can't go into composite, then at that point we can do the same thing again. Okay, so that's why we study these numbers. By understanding these numbers, when we get to more complex things later on, it gives us tools to solve the problems faster. So you definitely want to hold on to understanding prime numbers and composite numbers. All right, division is the reverse of multiplication. Okay, that's going to be important when we're working with algebra and linear equations. Okay, the answer to the division problem is called the quotient. Okay, a fraction is a division problem, and an average is also a division problem. So we use division a lot. So if you want to figure out a grade average, division is involved in that. If we're working with fractions, division is involved in that as well. Now we know that division is the inverse of multiplication. 6 times 2 is 12. 12 divided by 6 is 2. That means they share the same numbers in common. So you can use a multiplication problem to solve a division problem. And we can use a division problem to solve a multiplication problem. And just examples of the different ways we can express division. Division, like multiplication, has different symbols and ways that we can express it. Okay, division by 0 is not allowed. Okay, you cannot divide by 0. When we divide by 0, our answer is undefined. Okay, and that's an important concept in algebra. Division by 0 is not allowed. Okay, when we try to divide by 0, our answer is undefined. Properties of addition and multiplication, the commutative property. And the commutative property says that we can move the numbers around and still come up with the same answer. The associative property deals with changing the parentheses. And just because the grouping order changes or the parentheses change, we still come up with the same answer. That works with multiplication and addition. So multiplication and addition are associative and commutative. Distributive properties says that we distribute multiplication over addition or over subtraction. So we say A times B and then A times C. Other properties that we see are the identity property of multiplication and division. And the identity property simply says anytime we add something to 0, it's that number. And anytime we multiply something by 1, it's that number. Place value. Okay, we talked about the fact that our number system is based upon 10 digits. And so we count by powers of 10. If we got 345, the digit 3 is in the place of the hundreds, and it represents 3 hundredths. Okay, here's each place value has 3 units in it. Okay. And so we can see in our millions place, we've got 1 million, 10 million, 100 million. In our billions place, we got 1 billion, 10 billion, and 100 billion. When we're reading numbers in words, we start from the right and we break it up in number groups, okay, of 3 digits. Okay, so here we go. Okay, so the numbers read from left to right, but we break it up in digits, 3 digits. So, we'll basically go, and when we do that, we just pretty much, we start from over here as we do the breakup. And then we read that number, 32,841,796. And that's 796 ones. Okay. Notice how it's named after the, let me see if I can get it right here. Million here. What are 32 million? The thousands here for the 841,000. And then finally the 796 and 796 ones. Okay, because that first set of numbers are ones, the next set of numbers are thousands, the next set of numbers are millions. And then if we had one more set of numbers, it would be billions. Okay, here are the rules for rounding. Okay, if the digit to the right of a rounded digit is 0 to 4, we leave the digit the same and replace the digits to the right with zeros. If the digit to the right of the rounded digit is 5 to 9, we increase the rounded digit by 1 and replace the digits to the right with zeros. Okay, so here we're rounding to the nearest hundredths. Okay, so we're looking at the 8, whether it's going to go up or stay the same. Okay, and we look at the 6 behind it. If that number is 5 or more, the 8 goes up. If that number is 4 or less, the 8 stays the same, and all the other digits get dropped to 0. Yeah. Whether it goes up or stays the same, all the other digits are going to get dropped to 0 anyway. Okay. Another way of looking at it is we ask ourselves, is 867 closer to 900 or is it closer to 800? Okay, and the halfway mark is 850. Okay. Okay, and so here our answer is going to be 900 because 867 is closer to 900 than it is to 800. All right, so here's a problem here. Let's see if you guys can do this one. I want you guys to use estimating to come up with this answer. And go ahead and round it to the nearest hundreds place. And put your answers in the chat box. Okay, we got some interesting answers coming in here. We got 2009, we got 29,000, we got 3,000. Very interesting answers. How about everyone else? Okay, others? Oh, okay, Chris, not a problem. Okay, so there we go. Right into the nearest hundred place. And the correct answer is 2,900. So congrats to everyone who put 2,900 as the correct answer. Okay, here's another problem. Let's see if you guys can do this one as well. Mike bought a car for $1,750. He painted it and fixed it. He then sold the car for $3,200. How much profit did he make on the sale? Okay, interesting answer, 1,450. Okay, any other answers? Well, Joe, it says Mike bought a car for 1750, painted it and fixed it. Okay, so that's all in the 1750. He bought it, he painted it, and he fixed it for 1750. So all that's already in there. So that's all been given to you. It's just one thing for him buying, painting, and fixing the car. Okay, then he sold it. Okay, so one of the things we're gonna do is we'll subtract the original cost from the selling price. Now the approximate answer is gonna be 1,000 when we round, but that's not the exact answer. We're just using the approximate answer to figure out what the actual answer is gonna be. Okay, and so everyone that said 1,450 was actually correct. Okay, 3,200 minus 1,750 gave us 1,450. Okay, and so the 1,450 is approximate or close to 1,000, so the answer makes sense. So pretty much that's what we use approximating and rounding for. Much like if we went into, say, a restaurant and we wanted to tip a waiter or waitress, okay, and we spent like, say, $35 on a bill. Okay, we'll say, well, 10% of that is maybe around $3 or something, or $3. Or we could just take one of the zeros off the back end, and that gives us $3.50. Okay, and then if we wanted to, we can just say, well, we'll take that 350 and add another dollar to it and make 450. And so that's a decent tip. So that's what approximating or rounding is doing. We're trying to get the person around 15% without actually going through and doing all the math. Okay, here's a great video I think we can watch. Um, what I'm going to do is, before I do anything, let's see, I want to copy this. Let's go to the slide here. Let's see. Okay, I want to do this right here. I'm going to copy this video and give you guys the link to it in case someone has problems playing it. In case someone can't hear it, you can hear it later. All right, so that's the video. Then play from current. All right. Okay, so I like this video.
I is equal to 3.141592653589747, etc., etc. Hello, Donald. That's me. Very well. Mathemagic Land. It's the land of great adventure. Now, who are you? I'm a spirit, the true spirit of adventure. That's for me. What's next? A journey through the wonderland of mathematics. Mathematics? That's for eggheads. Eggheads? Now hold on, Donald. You like music, don't you? Yeah? Well, without eggheads, there would be no music. Come on. Let's go to ancient Greece, to the time of Pythagoras, the master egghead of them all. Pythagoras? The father of mathematics and music. Mathematics and music? Ah, you'll find mathematics in the darndest places. Watch. First, we'll need a string. Stretch it good and tight. Plunk it. Now divide in half. Plunk again. You see? It's the same tone, one octave higher. Now divide the next section. And the next. Pythagoras discovered the octave had a ratio of 2 to 1. With simple fractions, he got this. And from this harmony in numbers developed the musical scale of today.
Every day, a journey. The Syrian border, Cuba, the White House, America.
It's glad you're okay.
Oh, thank you.
And he's been there. Katrina, Egypt, Haiti, Japan.
Okay, that's enough of Donald. Okay, let's get Donald out of there. Okay, so I sent everybody the video link, so if you were having problems watching it with us, you can go back and watch it. It's in the chat box. Okay, so that's skipping that part. And I want to say next is the integers that we're going to be working with, and then that'll wrap us up for today. Integers have been around for a while. That's the negative and the whole numbers. Okay, we have a number line here, so we can see where the integers reside on the whole number line. Of course, they're the positive and the negatives, and the number 0 is also an integer. Okay, 0 serves as a starting point for integers. Okay, it's our place of origin, we say. Okay, so everything to the left of 0 is negative, everything to the right of 0 is positive. One of the things we look at is the absolute value of a number. And that absolute value is measured in that number's distance from 0. Okay, and absolute value is always a positive number. So if we're talking about the absolute value of 4, we're talking about 4 units from 0. They're going to be two numbers that's going to have the same absolute value. One of them will be the absolute value of -4 and the absolute value of 4. So we look at the absolute value of -9, it's going to be a positive 9. The absolute value of 378 is going to be 378. And then the absolute value of -6 minus the absolute value of -3 is going to be 6 minus 3, which is going to equal 3. And then if we have 2 times the absolute value of -25, that's going to be the absolute value of -25 is going to be positive 25. And then we'll simply say from there 2 times 25 is 50. Here we're adding integers using a number line. We start with a -4 on the number line because that's our first number. And then we'll go 3 more units to the left because -3 is a negative number. So everything to the left is negative. And so we're moving further away from 0 when we go -3. If we were moving closer to 0, we would go +3. And so that's going to leave us at -7. Okay, and -4 and -3 are going to be the same thing as -4 plus -3. And so we'll get the same answer as -7. Okay, so here's another one. We're going to start at -4. And then because that's a positive 3, like absolute value of 3, we're going to go back to the right 3 units. Because going to the right is positive. Going to the left is negative. That'll leave us at -1. Here's a mnemonic we use to remember integers. If the same sign we add and keep. If the different signs we subtract and take the sign of the higher number, then it'll be exact. So that's like a little integer wrap. So in this case, if we've got -4 and -7, the signs are the same. So we add and keep the sign. 4 and 7 is 11. And we keep the negative, so that's a -11. Uh, -8 and 12, they have different signs, so we subtract. 12 minus 8 is 4. And we take the sign of the larger absolute value. 12 is larger than 8, so our answer becomes 4. Okay, so -5 and -7 following the integer wrap. The signs are the same, so we add and keep the sign. 5 and 2 is 7, and that becomes -7. -3 plus -9 plus 3. The signs are different, so we subtract. 9 minus 3 is 6. The -9 has a larger absolute value than 3, so that becomes a -6. Okay, so we have a problem here. 5 minus 7. 5 minus 7 is really 5 and -7. So what you really got is a +5 and a -7. That's really what we got here. Okay, so the signs are clearly different here. So we find the difference between -7 and 5, and that gives us 2. The -7 has a larger absolute value than +5, so therefore it becomes a -2. Okay. And so 5 is positive, so we went to the right on our number line. 7 is negative, so we go to the left for the negative. And we end up at -2. Okay, so the left is always negative, the right is always positive. And we can see that on the number line if we look at it from a sense of directions. All right, here, we look at this problem here, we've got two negatives. Negative here, -3, and then we got a -5 here. So the signs are the same, so we add them. 5 and 3 is 8, and then we keep the sign in the problem, so it's going to be a -8. Okay, the signs are the same. -3 and subtract 3 is the same as -3. And if we use the number line, we go 5 units to the left for -5, and then another 3 units to the left for -3, and we end up on -8. Here, this one's a little different, and of course we can see that. We've got two negatives here together. Double negatives are positive. Okay, so double negatives are positive. So in this case, we've got a +3 and a -5. The signs are different, so we subtract. 5 minus 3 is 2. And then the -5 has a larger absolute value than the 3. Therefore, that's going to be a -2 again. Okay, so if we're combining more than two integers, okay, this is going to be a +2 here. So that's going to be a +2 and a +6. We can add these two together. And then we're going to have a -3 and a -4. And we can add these two together. These two will give us 8. These two will give us -7 or subtract 7. And the final answer will be 1. Okay, got -3 right here, -3 and -4 is -7. And 2 plus 6 is 8. And 8 minus 7 is 1. -7 and subtract 7 mean the same thing. Okay, and so we still come up with 1. Most of these problems can be done in your head if you know the rules. Okay, the more you know in math, the less work you do. That's why some people can get the answers so fast, because they know the rules real well. Okay, the same thing here. Okay, we got a bunch of negatives here. Okay, we've got negative. All this stuff right here can be combined. That's going to be -16 there. And then you just bring down the +11. Because you got -3 and -5 is -8, and -8 and -8 is -16. And then 11 added to that, that'll be -5 when you're done. And the way we do that, the integer wrap tells us if the signs are different, we subtract 16 minus 11 is 5. And then we take that large absolute value of -16 over 11, that becomes -5. Okay, and so we come up with that answer. Multiplication and division are a little different. The rules for multiplication and division are actually fun because it's the same rule. Let's work. Let's remember. If the signs are alike, the answer is positive. If the signs are different, the answer is negative. Okay, if you don't see a sign, then that means the sign is positive. 0 is not positive or negative. Okay, so double positives give us positive, double negatives give us positives, positive negative give us negative, negative positive gives us negatives as well. Okay, so here we go. -3, -5, it's going to be +15. Okay, negative positive gives us a negative 36. 9 divided by negative 3 gives us a negative 3 because the signs are different. Same here, the signs are different, so our answer is going to be negative. If we're multiplying or dividing, we got multiple integers. The way it works is if you have an odd amount of integers, an odd amount of negatives, your answer is negative. If you have an even amount of negatives, your answer is positive. An odd amount of negatives, your answer is negative. An even amount of negative signs. And when I say negatives, I don't mean negative numbers, I mean negative signs. So really what I'm focusing in on is right here, the negative sign itself. Because you can have an odd amount of numbers and some of them can be positive. Okay, so that's negative, negative. I got 3 negative signs there, so my answer is going to be negative because 3 is an odd number. Here I'm going to go through and count them up and see what I got. I got 1, 2, and 3 negative signs. So since there's 3 negative signs and 3 is an odd number, your answer is going to be negative. Okay, so you just simply go through and say 10 divided by 5 is 2, and 2 times 3 is 6, and 6 times 2 is 12, and I know my answer is negative because I've got 3 negative signs. Another concept that we come across is exponents in our order of operations. Exponents, of course, is a shortcut for multiplication. Okay, we have a base and a power. The base is the number that's being multiplied together. The power is the amount of times it's being multiplied. Okay, so instead of saying 2 times 2, 1, 2, 3, 4, 5, 6, 7 times, we can simply say 2 to the 7th power. And that means multiplying a bunch of 2's together 7 times. They equal 128. Okay, so the base is 2 and the power is 7. Okay, now if we have 2 times 2 times 2, then that's going to be 2 to the 3rd power. Okay, and on this one, that's going to be 3 times 3 times 3 times 3, which will be 81. And then, of course, anything raised to the first power is just going to be itself. So 4 to the first power is just going to be 4. Here, negative 2 raised to the second power will be a positive 4. Now, this one's different, okay, because it's not inside of parentheses. This one's actually going to turn out to be a negative 4. Okay, because we'll go 2 times 2, and the negative will be on the outside. Okay. The square root sign or the radical sign is what it's known as. Most of the times when we see it, we're dealing with square root, so that's why people call it the square root. Okay, so the square root of 4 is 2, and that's because 2 squared equals 4. So the square root is the inverse of the square. And so the square root of 25 is going to be 5 because 5 squared is 25. And the square root of 81 is 9 because 9 squared is 81. Okay, and we have a cube root here. The cube root of 8 is 2 because 2 cubed is 8. The cube root of negative 8 is negative 2 because negative 2 cubed is negative 8. And then the fourth root of 81 is 3 because 3 to the 4th power is 81. Okay, so I got another word problem for you guys. So if you can solve this one. Okay, now this one doesn't involve exponents or radicals. Okay, it just involves basic multiplication and addition. Okay, first answer is 400. Very intriguing. Okay, we also got 450 as an answer. Okay, any other responses? Okay, so let's look at this problem. All right, so you can either pay cash or you can finance. Now the cash is 1,500. Okay, and so we're wanting to know how much will she save. So at some point in time, we've got to subtract to figure out what the savings are, to figure out what's the difference between the cash and the finances. So that's why we got to subtract, because we got to figure out the difference between the two. All right, so the way we're going to do that is we're going to figure out that we got 100 down. And then if it's 150 per month, the word per means to multiply. And there are 12 months in a year, so that means per 12 or multiply by 12. And it's going to be 150 times 12. That's going to give us 1,800. So we're going to have 100 plus 1,800. It's going to give us 1,900 for our finance. Now we're still not finished because they wanted to know how much will she save, not how much does it cost to finance it. So we're going to take the 1,900, subtract the 1,500 from it, and that's going to give us 400. So congrats to everyone who came up with a response of 400. You did an excellent job. Now, another concept we'll see is order of operations. Okay, order of operations is important because we're going to see that in almost every math problem. Okay, even when we're not talking about order of operations, it's going to pop up, much like fractions and decimals do. We need to simplify using the parentheses first. Then we have exponents. Then multiplication and division are the same. And then addition and subtraction are the same. So that's why they're together. So we can remember that by the acronym PEMDAS or the mnemonic, please excuse my dear Aunt Sally. So either one of those will work. And an acronym is much like MAD, Mothers Against Drunk Driving. It's the first letter of each word to make up a new word. So the acronym PEMDAS, or we can use the mnemonic, please excuse my dear Aunt Sally. Okay, so when we're working with an order of operation problem, we do the grouping symbols first, which are the parentheses, brackets, brackets, absolute value bars. Then we do the exponents and radicals. Then we do the multiplication and division, left to right. Whichever one comes first, we do right first. And then we do the addition and subtraction from left to right. Whichever one comes first, we do first. Okay, so here's a problem. We do what's inside the parentheses first. 2 plus 3 is 5, and then 5 squared is 25. Here we got to do what's inside the parentheses first, because parentheses come first. 3 squared is 9, And 9 plus 2 is 11. And 11 times 3 is 33. Here we do inside the radical sign first. 4 plus 12 is 16. And the square root of 16 is 4. Here we do what's inside the parentheses first, negative 2 squared. And that's going to be a positive 4 because the negative 2 is inside the parentheses. So it's going to be a positive 4. And then we're going to have 3 minus 4, which would be negative 1. And negative 1 squared would be negative 1. Oh, I'm sorry, that's positive 1. Stand corrected. Okay, so here's one for you guys to do. Let's see if you guys can come up with the correct answer for this one. Okay, we got two answers of 66 and 56 so far. Okay, let's see. Another response. How about everyone else? We got very few responses here so far. Okay, Michelle has 78. Okay, Jose. Okay, do you guys need a little bit more time or are you ready to see the answer? Okay, so here's how we do it. We start inside the parentheses first. Work it all the way down. 2 squared is 4. 4 plus 3 is 7. Then the next thing we do is we square 7 next. That gives us 49. Then we multiply 3 times 49, and then we multiply 7 times 2. And then we add the two together, and we come up with 161. So congratulations to Renee and Chris, who came up with 161. Okay. Uh, at this point, we're pretty much finished with the math. One of the most important things, I don't think I can overiterate it, is that you need to make sure you review. Okay, by reviewing, you understand the concepts. If you need help, make sure you ask your instructors for help. Okay, reviewing jogs your memory. and it helps you to build your math knowledge. Okay, for your first week, you need to make sure you look at the rubrics. Okay, read the directions for week 1. Okay, um, spend time in Alex. Okay, you need to make sure that you're working on Alex before your next class. You need to make sure you're working on Alex, working on Alex, working on Alex. That's the end of our presentation. Okay. Um, does anyone have any questions at this point? The code for Alex Stanley is you don't really need the code. If you go into the Alex setup assignment inside of the FSO platform, you can just click that link and that will allow you to automatically register. Yeah, Francisco, you're going to need to re-register again. You're welcome. You're welcome, Caitlin. Um, the archive should be available. Um, I'm gonna try to record as soon as the session is over. I'm gonna start recording it, and then I'm gonna try to upload it to YouTube, and then I'll provide a link to everyone that was registered for the go-to training today. Okay, you too, Francisco.